Hello students. A warm welcome to 12th year students entering the new academic year 2020-2021. Hope you are staying safe during this corona pandemic crisis. Well, all around us we find so many elements which are classified as metals, non-metals and metalloids. A wide range of metals are used in our daily life. Inside our own body, a large number of metals are found. For example, in the blood we find iron, in the bones and the nails we find calcium, in the brain we have sodium. Apart from this, we also have selenium, potassium, lithium, copper, zinc, etc. Metals are also used in buildings and in constructions. They are also found in plants and animals, in the earth and in the universe. Hope you have now guessed what we are going to discuss in today's chemistry class. We are going to learn about metallurgy. Today's class we are going to learn about metallurgy. Metallurgy is a science of extraction of metals in their pure form. When we talk about metals, they are basically elements with a set of characteristic properties. So the elements with the set of characteristic properties are called as metals. They have a separate set of properties differentiated from the non-metals. I would like you to go back and recap what are the differences between metals and non-metals. Now when we talk about the metals, they are classified into three types: the highly reactive metals, the moderately reactive metals and the less reactive metals. Highly reactive metals, they occur as compounds. Some of the examples are alkali metals like iron, calcium, lithium, etc. The moderately reactive metals, they form compounds and exist as compounds and individually as well. Some of the examples would be copper, which is available in the free state as well as in the combined state. The less reactive metals are found in the native form. They do not react with other metals, so they are also considered as inert. And a good example of the less reactive metal will be gold, silver, platinum, etc. When we consider the pure metals, they have certain characteristics. Most of the metals are lustrous, malleable and ductile. Lustrous means they are shiny in nature. Malleable means they can be beaten into thin sheets, and ductility means the property in which the metal can be taken up into thin wires. Now copper, silver and gold as well as platinum, they are least reactive elements. The native elements, they do not easily combine with other elements. They are platinum, gold, silver, etc. The reactive metals, like the alkali metals, are present or found in the combined state. Now, when we look at the series of metals like potassium, sodium, lithium, calcium, magnesium, etc., they are highly reactive. And aluminium, zinc, iron, tin and lead, they are moderately reactive, whereas silver, gold and platinum are least reactive. So this forms the reactivity series of the metals. So the decreasing order of the chemical reactivity is being represented here. The processes involved in metallurgy is called as a metallurgic processes. So what is metallurgy? Metallurgy is a process of extracting metals from their ores and refining the crude metal into a pure form. Now for the extraction of metals, let us consider why metals have to be extracted. Now, metals have to be extracted because they are being used in various fields. They are used in making alloys, they are used in constructions of buildings, and they are used in modern technology. Now, how to extract the metals? When we extract the metals, they should be eco-friendly, they should minimize the waste, and they should maximize the energy efficiency. what are the different steps involved in extraction of the metals? Different steps involved. First will be the ore has to be concentrated. So concentration of the ore. Secondly, we have to extract the crude metal from the concentrated ore. So extraction of the crude metal from the concentrated ore. And after extracting the crude metal, you have to refine it. So the third step would be refining the crude metal to obtain the pure metal, which in order to remember this, you can remember it as CER. C stands for concentration, E stands for extraction, and R stands for refining. Now there are some important terminologies which are being used. In metallurgy. Now among them, first would be about minerals and ores. Let us find out how to distinguish between minerals and ores after finding out what are the definitions of minerals and ores. Minerals are naturally occurring substances. They contain the metals in the free state and in the form of compounds. The compounds may be in the form of oxides or sulfides. Some of the examples of the metal be bauxite and china clay. These are the minerals of aluminium. Now what are ores? Only those minerals which contain a high percentage of the metal which can be extracted conveniently, economically and profitably, they are called as ores. Now here we saw bauxite and china clay are minerals of aluminium, whereas bauxite is considered to be the ore of aluminium and not china clay. China clay is considered as a mineral. Now here let's say that this is the mineral that is being found and in which a very small percentage of the metal is present in it. In the next picture you will have a little more higher percentage of metal being present in the mineral, and in the third picture you find a very high percentage of the metal is being present in the mineral. So this is better used for the extraction of that particular metal. The percentage of the metal differs. For example, in iron, hematite and magnetite ores, they contain high percentage of iron. So they are used effectively in the extraction of metal. That is the reason why we say all ores are minerals, but all minerals are not ores. All ores are minerals, but all minerals are not ores because of the lower concentration of the metal. Now let us look at the list of metals, their ores and their formula. We have different metals here like aluminium, iron, copper, zinc, lead, tin and silver. Now the ores and their compositions, you will have to have them by heart. Aluminium, the three ores of aluminium would be bauxite, diaspore, kaolinite. Iron has got the ores as hematite, magnetite, siderite, iron pyrite, limonite. Copper, the different ores of copper would be copper pyrite, copper glans, kyprite, malachite, azurite. The ores of zinc would be zinc blende, ZnS, calamine, zincite, ZnO, and the ores of lead are galena, angelcite, cerussite. The ore of tin would be tinstone or cassiterite. The ores of silver are found to be silver glans, Ag2S, pyragorite, chloragorite, stephanite and prousitite. Now let's go on to how the ores can be extracted. The extraction of the ores involves from the concentration. The ore has to be concentrated first and then it has to be extracted. So after concentration of the ore, we go on to the extraction of the crude metal. After the extraction is over, we go on to the refining of the crude metal. So refining of the ore of the crude metal is done. Let us concentrate on the concentration of the ores. Before extraction, the impurities in the ore should be removed, and this process is known as concentration of the ore. The impurities can be in the form of non-metallic impurities, in the form of rocky materials, and in the form of siliceous matter. All these three are being called as gangue particles. So what are gangue? They are the impurities which are present in the ore in the form of non-metallic impurities, rocky materials, and siliceous matter. They are called as gangue, which has to be removed. So the concentration of the ore depends on various factors like the nature of the ore, the type of the impurity, and the environmental factors. Now, concentration of the ore can be done through various methods, but through gravity separation, froth flotation, magnetic separation, and through leaching. Now, a small gist of what is gravity separation, froth flotation, and leaching. Gravity separation, the ore having high specific gravity is separated from the gangue particles with low specific gravity, whereas froth flotation is usually used for concentrating a sulfide ore by a preferential wetting principle. Leaching, this is based on the solubility of the ore in suitable solvents. Like leaching can be of the cyanide process, ammonia leaching, alkali leaching, and acid leaching. In magnetic separation, we find this is applicable to ferromagnetic ores which contain iron particles in them, and this is based on the difference in the magnetic property of the ore and the impurities. First, let's go on to in the concentration of the ore, the concentration of the ore through gravity separation. As the word implies gravity, so there are high specific gravity of ore particles and low specific gravity of the gangue particles. Gravity separation is also known as hydraulic wash, and it is a method to concentrate the ore, and it is based on the difference in the specific gravities between the ore and the impurities, which we call it as a gangue particles. Let's see an outline of this gravity separation. The ore is first crushed into a fine powder, and then it is being treated with a water current which flows down. And during this process, the lighter gangue particles, they are washed away by the water, while the heavier ones settles down near the corrugated boards. So as you see here in this diagram, the crushed ore is fed into this method, and there is a sloping table through which water enters, and the crushed ore material, depending upon their specific gravity, the high specific gravity ore materials, they get settled down near these boards, the corrugated boards, while the low specific gravity gangue particles or the impurities get washed away with the water and they get separated out. And if we want, we can try this out once again. We can put it into this funnel here and do the method once again. So this method is called hydraulic washing of the ore. Other words, we call it as a gravity separation. The second method for the concentration of the ore would be called as froth flotation. This is a method which is commonly used to concentrate the sulfide ores, especially galena and zinc blende are some of the examples ores which undergo froth flotation. The basic principle involved in froth flotation will be the preferential wetting of the metallic ore to separate the gangue particles. The crushed sulfide ore is suspended in water, and with the addition of a frothing agent like pine oil or eucalyptus oil mixed along with small quantities of ethyl xanthate, which is used as a collector, we get the concentrated ore. Froth flotation. This consists of a container. We first have to draw the container, and it has a feed through which the crushed ore material is being fed into. And here you at the bottom you have the tailings, which means that the waste material, the water and the waste materials go away, are taken off through the tailings. This whole container is being filled up with water. It is being fixed with a stirrer, and a supply of air is being sent inside with the help of a controller. Now for the stirrer to keep moving, we have a motor being fixed and which rotates, and through the feed you are having the crushed sulfide ore, which is mixed along with the pine oil or the eucalyptus oil, which is a frothing agent, and it has to be stirred properly. When it is being stirred fastly, you will find that along with the collector molecules, they get attached to the ore particles and they make them water repellent and forms a froth. It forms a froth which comes outside, can be collected. As a result, the ore particles wetted by the oil rise to the surface along with the froth. The froth is skimmed off and dried to recover the concentrated ore. The gangue particles that are preferentially wetted by the water settle at the bottom, which can be removed through the tailings. When the sulfide ore of the metal of interest contains other metal sulfide as impurities, depressing agents such as sodium cyanide and sodium carbonate, they are used selectively, which prevents the other sulfur impurities from coming to the froth. If more than one sulfide ore is present, ores are present, for example, in the extraction of lead from galena, two sulfide ores such as PbS and ZnS are present, in which ZnS is considered as an impurity. To remove this impurity of ZnS from galena, a depressing agent like sodium cyanide is being used. Sodium cyanide is added to depress zinc sulfide impurity in galena from forming froth by complexing it with zinc sulfide to form a complex Na2Zn Cn 4 times, which is a coordination complex, which is named as sodium tetracyanozincate, which can be removed. As we shall continue to study about the other methods of concentration of ore and extraction of the crude metal in the next class. Thank you.